Hi there everyone, welcome back to Cody's Lab. So I was working on a pump for my chloralkali cell and I stumbled across something that I thought I'd share with you guys. So I have here an alkaline battery with two magnets stuck to the end and a pool of liquid mercury. Now watch what happens if I lower this down into the pool of mercury. And I'm going to hold on to it here, just kind of touch the surface. Look at that. The mercury shoots off that way. Now, watch what happens if I let this go. Isn't that lovely? It's like a little boat, just motoring its way across the pool of mercury. I love the sound it makes too. And if I take one of the magnets and flip it around, you'll see what happens. Now it just spins like this. How about that? Oh, it got hot. Yeah, I guess it is a direct short, basically. So let me see if I can explain what's going on here. So these dots represent magnetic field lines coming up out of the paper. So turning to the side, the field lines would look like this. Of course, little vector arrows here. I guess these would be little crosses. Now if I shoot an electron into this, the electron interacts with the magnetic field, causing it to deflect. So the electric field's coming up out of the paper, the electron gets deflected the direction that my fingers are curling here. And it's always going to be deflected at a right angle to the magnetic field. So what's going to happen is the electron's going to spiral until it finally manages to get out of the magnetic field. Incidentally, spiraling electrons create a magnetic field. I explained this a little bit better in another video, one where I actually made the world's first electric motor. I'll put a link down in the description so you guys can go watch that. So now when I take my little device here, the magnet is right there. Let's just take it away so we can draw this. And the other magnet's down here. This is the negative end, and this is the positive end of the battery. And as for the magnets, this is the north end of the magnet and this is the south end of the magnet. And this magnet over here is actually flipped so that this is the south and this is the north. So the norths are facing out. So the magnetic field lines are coming out around the magnet just like this. And they are of course symmetrical, but for ease of seeing this, I'll draw the direction of the electrons on the other side here with a dotted line. The electrons are going out from the negative end, but I'll start drawing them here from the positive end, through the magnet, through the highly conductive mercury metal, back around through the other magnet and into the other end of the battery. Electrons, of course, go negative to positive. I think that's how they work. If I'm wrong on that, blame Ben Franklin. So the electrons are going that way, magnetic field's going this way. The electron is going to be wanting to be curved up over here and down over here. So how I had it in the pool would have been like this. So down here, up on the other side. And then over here, everything's switched, so it would be opposite that. So it'd be down here, up here. The electron's going the other direction. It depends on the direction of the electron and the direction of the magnetic field, which direction they get curved. And as the electrons get curved, they drag the mercury with it. So the mercury ends up doing a spiral, kind of like this. It's kind of hard to draw in 2Ds. But since the mercury can't go in a complete spiral, it ends up shooting out in that direction. And over here, it shoots out in the same direction, except for when I had the magnets flipped, in which case it shot out in the other direction. So now we essentially have the magnet shooting the mercury away like a rocket, and it's generating some thrust. So you have equal and opposite reaction. As the mercury is being blasted away, it is pushing against our device, but it's only pushing against the bottom portion here, and so it causes it to rotate. And since this magnet has flat faces, it kind of acts like a paddle, and it's able to kind of walk along and actually move along the mercury in the opposite direction you'd think it should. I just thought that was really cool. We can, of course, test this by using some round magnets. So let's try putting it in here now. Okay, so it still spins like that. Let's flip one of these over. Try to center it. You see, it's not paddling forward, it's just kind of wandering around aimlessly. You can still see it spins quite quickly. It's because it is still able to push on the mercury. And this battery, of course, moves a lot less than the mercury does because the mercury is just so heavy. But holding it in place, it does still shoot it off. And actually, let's try putting the battery down farther. See? Once it is submerged in the mercury, instead of shooting off to one side, the mercury actually is able to continue to rotate all the way around. For the final test, let's put this device down on some conductive aluminum foil and see if it moves. Nope. So it really needs to be the mobile mercury. Hope you enjoyed. I'll see you next time.